We present single-camera 3D head fitting for clinical mixed reality applications. For many medical conditions, it is notoriously difficult to track hair or skin changes over time. While there are many works on 3D head reconstruction, most have focused on accurately reproducing the face, leaving the scalp to a statistical approximation. Our goal is to recover the person's head so that it may be used for mapping clinical information. Given an input video, we apply a structure for motion and multi-view stereo pipeline to recover camera information and a dense 3D reconstruction of the person. We then fit and align a 3D morphable model in a new two-stage optimization approach. In stage 1, we use the structure for motion reconstruction and the frontal frames to determine an initial fit of the head using only facial landmarks extracted by traditional detectors. In stage 2, we define adaptive scalp features using the silhouette of the 3D reconstruction at each frame to provide additional information on the scalp shape. Scalp features, along with estimated facial landmarks obtained from the frontal fit, are then used to fit the 3D morphable model across all poses. The result is a final fit that closely contours the entire head. Our approach recovers consistent geometry for varying head shapes from videos taken by different people with different smartphones and in a variety of environments, from indoor living rooms to outdoor spaces. Shown here are sample frames with the final projected meshes visualized as both wire frame and solid shapes. In order to work, the method requires minimal hair volume. Once a 3D mesh is obtained, however, it can be registered with other videos of the same person. This allows us to recover the underlying shape for different hairstyles as well as larger hair volumes. Here is an example of the output mesh anchored back on the original video. Once obtained, it can be used to map image texture information like the hair density shown here. Thanks to the consistent mesh topology of the 3D morphable model, the mesh can be used to easily compare a specific location on a person's scalp at different time points as well as between subjects. In the future, we would like to run this in real time so that the visualization can be superimposed directly on the person in a mixed reality environment.